So this chapter talks about rational functions. I highlighted it up there. Rationals. Okay, so what are rationals? Well, rationals are just fractions. Why don't they call them fractions? Well, because they're algebraic fractions. Okay, they have monomials, binomials, and trinomials in them. Okay, they're not like fractions like 1/2 or 2/5, right? But they're essentially the same thing. So today we're going to simplify them, reduce them. We're just reducing fractions. That's all we're doing. Okay, reducing fractions like you guys have been doing for years. It looks a little different because they're monomials, binomials, and trinomials, right? But the steps that we use, you guys have done before, okay? Expressions just means no equal sign. Anytime you see the word expression, what does that mean? No equal sign. Like 1a and 1b don't have equal signs. That's all it means, okay? If there are equal signs, then it'll say equations, okay? All right, so here we go. So the top of a fraction is called the numerator, 15. The bottom of a fraction is called the denominator, 2x or 20x to the third power. Okay, so these are both monomials. 15 is a monomial. 20x to the third is a monomial. Okay, so how do we reduce monomials? Well, first thing you do is start with a number, 15 and 20. What's the biggest number that goes into 15 and 20 evenly? 5, right? So you divide them both by 5. 5 goes into 15 3 times. 5 goes into 20 4 times. So now you don't have 15. You have 3. And then 4 times x to the third power, right? Times x to the third power. Because it was multiplication initially, right? Okay, so 3 and 4 we can't simplify anymore. X to the third. The only time you can simplify x to the third is if there was an x up here. If there were any x's up here, you could simplify it, but there aren't. So that's as far as we can simplify it. Okay. All right, let's do letter B. So it's 24 times a times b to the second power, and 32 times a times b. Okay, it's all multiplication. So that's one term. There's no adding or subtracting. There's no pluses or minuses here. So it's just one term. It's a monomial over a monomial. So let's start with the numbers. What's the biggest number that goes into 24 and 32 evenly? 8, right? I think 8 is the biggest. We always want the biggest number. 8 goes into 24 3 times. 8 goes into 32 4 times. Okay, so let's make our reduced fraction. So we're going to have a 3 and a 4. A has a power, right? First power. Okay? So A is a number. It's up here and it's up here. We don't know what number it is, but it's a number. We treat A like a number, right? So what if we had the same number divided by the same number? What would it always be? 1. So A to the first power divided by A to the first power reduces to 1 over 1, right? So it doesn't disappear, but it becomes a positive 1. Okay? B's now. B's are close. It's not exactly the same because B on top isn't B to the first power. This is B to the second power, right? And this guy is just B. So anything divided by itself, B divided by B makes 1. But we can't do that with the other B because we're all out down here. So it stays. So let's take a look at what we got. On top, I have 3 times 1, 3, times 1 again, also 3, times B. So on top, I have 3 times B. Because all those 1s are just times 1, times 1. Anything times 1 stays the same. On bottom, I have 4 times 1 times 1. 4. No A's or B's left on the bottom. You're done. Okay, that's how you reduce or simplify monomials. Okay? So now, what else do we have besides monomials? Well, we have binomials and trinomials. That's what we're going to spend the rest of our time doing. Okay? So here are the steps, and then excluded values. But let's just do the problem because I think you guys will find it familiar. Okay? So we have a fraction. I have a numerator and I have a denominator. The numerator, because it says simplify, the numerator is x squared minus 7x plus 6. The denominator is x squared minus 5x plus 4. Anytime we reduce binomials or trinomials, the first step we always do is factor them first. So we're going to factor the yellow and the green. Okay? So let's start with the yellow. So the yellow is x squared minus 7x plus 6. Is it a monomial, binomial, or trinomial? Trinomial. How do we factor a trinomial? We have steps there. You have steps in your notes. You have steps over here. That's why I left them on here, because I knew we did it first chapter, second chapter, third chapter, fourth chapter. That's the one thing that we kind of do throughout the year is factoring. Okay, so that's why I left them up there. So if it's a trinomial, first thing, are the powers in the correct order? Yes. Is there a GCF besides 1? No, right? So next is ABC. A, B, C. Right? So you got to multiply 1 times 6. And the bottom is negative 7. What are the two numbers that multiply the top and add to be the bottom? There you go, negative 6 and negative 1. Okay. So we get minus 6 and minus 1 with an x and an x, right? That's step 3 for trinomials. Step 4, or forgot step 3, bottoms up. Divide by a. A was 1. So we had x minus 6 and x minus 1. Are any of those difference of squares? No, they don't have the correct powers, right? X minus 1 is close, but doesn't have the right power. So we're done simplifying them. So we're going to move it back. I'm going to move it back, and instead of the trinomial, I have the factored version. X minus 6 and x minus 1. It's the same thing. They say the same thing. The only difference is one's factored and one's not. Now we're going to do the same thing with the green, the highlighted green. X squared minus 5x plus 4. So I'm going to ask this question a lot because it's one of the most important questions. Is this a monomial, binomial, or trinomial? Trinomial. So we're going to do the same steps. Is it in the correct order? Yes. Is there a GCF besides 1? No. So let's go to ABC. A is 1, B is negative 5, C is positive 4. Has to multiply to be 4 and add to be negative 5. Negative 4 and negative 1. Divide by A. X minus 4 and x minus 1. Okay. Are any of those difference of squares? No, because they don't have the right power. They're close. They're both very close because 4 and 1 are on my list. But the power is not correct. So we're going to put these down here. So instead of the trinomial that was in green, we now have the factored version. That's the most important step, factoring it, because if you do that correct, your next steps are very easy. So now, the multiplication this binomial is multiplying times this binomial, and this binomial is multiplying times that binomial. I'm not going to do a box because then I'd get back to where I started. I don't want to do that. What I want to do is see if any binomials are the same. Are any of those binomials the same? X minus 1, right? Anything divided by itself, doesn't matter if it's x minus 1 or a number, equals 1. So this guy divided by itself makes a 1 up here and a 1 down there. They don't go away. They don't disappear, but they become positive 1. Now, x minus 6 and x minus 4, those are close, but they stay because they're not exactly the same. So what do we have left? I have 1 times x minus 6, and I have 1 times x minus 4. Well, distribute. You get x minus 6 and x minus 4. So this is what I've seen. I see this every year. Not a lot, but I see it enough that I want to show you. So look up what I'm going to do here. I have students do this. Oh, we have x, right? X, those cancel out to be 1s. And then I can divide this by 2, and I can divide this by 2. So negative 3 over negative 2 is my final answer. Is that true? Can I do that? No. You can't do any of that. Because how do we simplify binomials? They have to be exactly the same. It has to be x minus 6 and x minus 6. Can't be close. It has to be the same. And since both of these binomials are different, we're done. Don't force anything. If you can cancel it out, great, but don't force it, okay? All right. Okay, let's look at, or actually I want you to do B on your own. Do B on your own just like we did A, okay? All right, so the top is a trinomial, the bottom is a trinomial. So you just factor it like we do trinomial steps, just like we did on part A, question A. So on bottom you get x plus, on top, sorry, the yellow makes x plus 5 and x minus 2. The green on the bottom makes x minus 2 and x plus 1. Okay. Once you do that, then you look for binomials that cancel out, right? Because this is binomial times binomial. There's no adding or subtracting in between the binomials. So we have an x minus 2 divided by x minus 2. Anything divided by itself makes positive 1. Then I have x plus 5 left, right? And x plus 1 left. I can't simplify those since those are not the same binomial. You're done. Okay, you are done. All right. All right, so let's look at letter C. Okay. So we have a numerator on top, denominator on bottom. Big question again. Start with the yellow. Is the yellow monomial, binomial, or trinomial? Trinomial. So we're going to do exactly the same steps we've been doing. Nothing's going to change. They won't always be trinomials, but this one is. Okay? So we get x to the third power minus x squared minus 42x. So since it's a trinomial and we want to factor it, first question we're going to ask ourselves is it in the correct order? Yeah. Is there a GCF besides positive 1? Yeah, this one does, right? Sometimes they'll sneak one in there that does have a GCF, so you always want to do a GCF first. So we get x. If I take away a power, so a is 1, b is 1, negative 1, sorry. C is negative 42. So let's see, 1 times negative 42 is negative 42, and negative 1 on the bottom. I'm not even going to ask you what the two numbers are, because I think you guys know what the two numbers are. Okay. So we get minus 7, x minus 7, and x plus 6. Don't forget about your GCF, though. GCF always comes along and is in the front. Divide by a. Divide by a. So you get x minus 7 and x plus 6. That's what the yellow reduces to, or simplifies to, or factors to, whatever word you want to use. So I'm going to put that on top. Okay. Now the green. 2x squared minus 20x plus 42. Trinomial. Order is correct, but does it have a GCF besides 1? Yeah, positive 2, right? So we got 2 in front. X squared minus 10x plus 21. A is 1, B is negative 10, C is 21. A times C, 1 times 21 is 21. Negative 10 goes here. What are the two numbers that multiply to be 21 and add to be negative 10? Negative 7 and negative 3. So don't forget about your GCF. That goes in front. And I got x minus 7 and x minus 3. Divide by a. So I get x minus 7 and x minus 3. So that's going to replace the green. 2, x minus 7 and x minus 3. Okay. I'm going kind of fast. I know I'm going kind of fast with the factoring because you guys have been doing it since September, I think. We've been doing it maybe August. So it's just like a lot of the same. So okay, once you do that, binomials. Let's start with binomials. Any of the binomials that I can cross out and make ones? X minus 7 and x minus 7, right? Those become ones. I only have two binomials left, x plus 6 and x minus 3. They're not the same, so I can't touch them. I do have monomials, though. The x in the front is a monomial. The 2 on the bottom is a monomial, but I can't simplify those, so I leave them. So on top, I have x times 1, which is x, times x plus 6. On the bottom, I have 2 times 1, which is 2, times x minus 3. Can't reduce them anymore. You are done. You are done. Simplified them, reduced them as far as you can. Okay. The last thing is multiplication and division. It's not that big of a deal. It's just more of the same. There's not a lot of multiplication. There's not a lot of division.
How do we truly know if we're like fully done?
So if you're fully done, check binomials with binomials. If your binomials don't match, you're done with the binomials. And then if you have numbers in front, like x and 2, can I reduce those? If your answer is no, then you're done. Okay, you're done. Good question. We're going to see more like that. That's a good question. Because I have students always, like, they put an answer in Delta Math and it says wrong. And they're like, why? I did everything right. They just forgot to reduce something. So yeah, we're going to see more like that so that you'll know, like, when am I done and when do I have to keep going? Okay. Multiplying. How do we multiply fractions? Like if I have two fractions that I want to multiply times each other. 1/2 times 2/5. If I want to multiply fraction, what's the rule for multiplying fractions? Straight across, yeah, straight across. 2 times 1, 5 times, so it would be 2 times 1, 5 times 2, and then reduce it, right? And then you're done. It's the same thing. Straight across. Multiply straight across. So we're going to go 6x to the third times 4x to the third, and then 7 times 3. Six, that's a 6, not a B. 6 times 4 is 24. What's x to the third times x to the third? So I have a question over here. What's x to the third times x to the third? X to the 6 or x to the 9? It's actually to the 6. This one is to the 9. If you have a power to a power, that's to the 9. So it goes like that and like that. Okay, so we have x to the third times x to the third. Okay, so x to the 6. And on bottom, 21, or 7 times 3 is 21. Reduce it. 24 and 21, what's the biggest number that goes into 24 and 21? 3, right? 3, yeah. 7 goes into 21, but it doesn't go into 24, and 8 goes into 24, but not 21, so 3, I think, is the biggest. So this becomes an 8, that becomes a 3. So you have 8 times x to the 6th over 3. The bottom, yeah, the bottom would be 7, yes. Thank you. 7. I don't have any x's on the bottom, so I can't do anything with the x to the 6th. So you're done. So that's monomials. All of these guys are monomials. All of these guys here were monomials, right? So what if we mix in some binomials and trinomials? You're going to do exactly what you did earlier today. Okay, so let's look at B. Don't even worry about the multiplication. Multiplication's meaningless right now. It's really meaningless. Okay, what I'm worried about is factoring. Factoring. I have a yellow, I have a green, I have a pink, and I have a blue. Okay? I want to factor each of those, just like you've been doing. Just like you've been doing. Okay, so let's start with the yellow. Is that a binomial, trinomial, or monomial? Try. Do what you've been doing. Nothing changes. That part does not change. Okay, so we got order is correct. GCF is just 1. ABC. One times negative 24 is negative 24, negative 5. What are the two numbers that multiply to be negative 24 and add to be negative 5? I believe 8 and positive 3. Divide by A, divide by A. That's going to replace the yellow. So the only difference when we're multiplying is we have two fractions being multiplied times each other, right? Now we're just going to put them under one. So we're going to put everything that I simplify onto that one fraction. So the yellow now becomes x minus 8 times x plus 3. Yellow is done. Yellow is simplified. Let's go right across because we multiply straight across, right? X squared, is that a monomial, binomial, or trinomial? Monomial. So monomials we don't reduce, we just rewrite. Don't need to reduce it, just rewrite it. Now we got the green. Let's go to the bottom now. Is the green a monomial, binomial, or trinomial? It's a binomial, so we're going to use the binomial steps. We haven't used them yet, but we know them because we've been doing them for chapters, right? For a few chapters now. Binomial steps don't have as many. Same two, first two are the same. Is it in the correct order? Yes. Is the GCF different than 1? No. The only other steps is difference of squares. Is that a difference of squares? It is a difference of squares. Because 1 in front of x squared is on my list, and then 9's on my list. There's a minus in the middle, and a power is even. All of those make difference of squares. So half the power, 1's a plus, 1's a minus, and then what is it going to be? Plus and minus, 3. Are any of those difference of squares? No. So we're done with the green. I'm going to put those back. You notice how the green was on the bottom of the fraction. So now I'm going to put it on the bottom of this fraction. It's going to take the place of the green. X plus 3, x minus 3. Now the last one is the blue. Monomial, binomial, trinomial. Binomial, okay? So binomial steps. Order is correct. Is the GCF anything other than 1? No. Is this difference of squares? No. It's done. It's factored. It was already factored to begin with. That happens sometimes. The better you do those steps, I know it takes a little bit of time to do those steps, but the better you do those steps makes the next step easy. So let's look for binomials that cancel out. Are there any binomials that are going to cancel out? X plus 3 and x plus 3, right? They become 1's. Any other binomials that cancel out? X minus 8 and x minus 8, right? I'm out of binomials on top. So there's no more binomials that can change. So let's write what I have. On top, I have 1 times x squared. That's just x squared. On bottom, I have 1 times x minus 3 times 1. That's just x minus 3. You could put the 1 in the front, but really it doesn't change anything, right? Because you distribute, it's still going to make x minus 3. Okay, so on top I have a monomial. On bottom I have a binomial. They're not the same, so I can't even try anything because they're not even the same type of term. This one's a binomial, the top is a monomial. You're done. Don't try to cancel out the x's or anything. Don't do that because they're not the same. Okay? So ask yourself, binomials, can I cancel out any? Do all those. Monomials, can I do anything? Well, there's only one monomial on top, not on bottom, so you can't cancel out anything. Okay? All right, one more. We got plenty of time. One more, we're done. Okay. Dividing fractions. So multiplying, we multiply straight across, super easy. How do we divide fractions? Well, there's different ways, but the way I remember are 3 words. Keep, change, flip. Keep, change, flip. Only with division, not multiplication, only with division. So what does that mean? It means the first fraction we keep. Don't change anything about the first fraction. Leave it the way it is. Keep. That's what keep means. Change. What do you think we're going to change? Dividing to, what's the opposite? Multiplication, right? Multiplication. Change that to multiplication. Flip. Flip the only thing that's left, the second fraction. Flip it so that 3x is on top and the trinomial is on bottom. Now we do exactly the same thing we did on the last problem, on B right above it, because it's a multiplication. All right? Once you do that, then it becomes a multiplication problem. We have, oops. Yep. Go through, simplify. Start with the yellow. Monomial, binomial, trinomial. Binomial. Order's correct. GCF, just one, right? Is it difference of squares? Yes, it is. Seven and 7. None of those are difference of squares anymore, so that is going to be what swaps with yellow. So since yellow is on top, I'm going to put x plus 7 and x minus 7 on top as well. Go right across. 3x. Monomial, binomial, trinomial. Monomial, so we just rewrite it. Times 3x. Go to the bottom. Green. Green, binomial, or monomial, binomial, or trinomial? Binomial. So let's go to our binomial steps. Powers in the correct order. Is there a GCF besides 1? Yes. How many x's can I take away? 3, right? So x3. What does that leave? X plus 7, right? Is x plus 7 difference of squares? Nope. So the green is now this. So I'm going to move the green. Since it was on the bottom to begin with, it's going to be on the bottom over here. Blue. I think we did the blue. I think we did one like this earlier on a problem. This trinomial. It's a trinomial. And I think we did one earlier with the same exact, or very similar to it. I think we did it on the front page. Trinomial, GCF, order's in the right order. GCF is 1, ABC. Negative 42 and negative 1. I'm not going to say the numbers, you guys know them. Okay, so x minus x plus. Divide by a. Any of those difference of squares? Nope. Move them back in. Okay. Start with binomials. Any binomials I can simplify to be 1. Yeah, x plus 7 and then x minus 7, right? Okay, so let's see what we have left. On top I have 1 times 1 times 3x. On bottom I have x to the third times x plus 6 times 1. If I were to put that answer in Delta Math, they'd say wrong, because I didn't ask myself, how about the monomials? 3x and x to the third. Those are both monomials. I can cancel out things there, right? Because this guy has x to the first power, right? So I can take away powers. I can take away 1 power and 1 power, just like you did on example number 1. This goes away. That becomes a power of 2. So you have 3 over x squared, x plus 6. Now I'm done because there's no binomials to cancel out, and the monomials, 3 and x squared, can't cancel out, so you're done. Now you know you're done. Okay? All right, so you're going to put that in page 23. Tape's in the back. Tape that into page 23.